Assistant Professor at LJ Institute of Engineering and Technology. Today I will teach you new unit, that is improper integrals. And in this unit today I will teach you new topic, that is improper integrals of type 1, type 2 and type 3. So let's start. So first of all, we will see actually what is the meaning of improper integrals. The integration from a to b fx dx is called an improper integral if one or both limits of integration are infinite. Or this is the second condition, function f of x becomes infinite at a point within or at the end points of the interval of integration. So whenever you have been given the integration of the form integration from a to b f of x dx, and if its one-off limit or both limits are infinite, or the function f of x becomes infinite at a point within or at the end points of the interval of integration, then that type of integration is called improper integration. Now we will see improper integrals of the type 1. The integration from a to b f of x dx is called an improper integral of type 1 if either lower limit or upper limit or both are infinite. For example, this is the integration from minus infinite to b 1 upon 1 plus x square dx. Here the lower limit is minus infinite. Then after in this integration, which is integration from a to infinite 1 upon 4 plus x square dx, here its upper limit is infinite. And this is the third integration from minus infinite to infinite 1 upon a square plus x square dx. Here both limits are infinite. One is minus infinite and other is plus infinite. So whenever you will find the integration and if its one limit or both limits are infinite, then those type of integrals are called improper integrals of the type 1. Now we will see improper integrals of the type 2. It is definite integral in which integrand become infinite at one or more points within or at the end points of the interval of integration. For example, integration from 0 to 1 upon x dx. Here function 1 upon x is not defined at x equals to 0. Now in this integration, which is integration from minus 2 to 2 1 upon x square minus 1, this function is not defined at x equals to 1 and at x equals to minus 1. Then after integration from 0 to 4 1 upon square root of x minus 4, this function is not defined at x equals to 4. So all these are the examples of improper integrals of the type 2. Now we will see improper integrals of the type 3. It is definite integral in which one or both limits of integration are infinite and the integrand become infinite at one or more points within or at the end points of the interval of integration. So actually this is the combination of type 1 and type 2. Thus it is a combination of improper integrals of type 1 and type 2. So this is the example, integration from 0 to infinite 1 upon x square dx. Here the one limit is infinite and the function 1 upon x square is not defined at x equals to 0. So this is an example of improper integrals of the type 3. Now we have problems related to these topics. Evaluate integration from 0 to infinite 1 upon x square plus 1 dx. Here the given integral is an improper integral of the type 1 because its one limit, which is upper limit, is infinite. Integration from 0 to infinite 1 upon x square plus 1 dx. As this upper limit is infinite, so we will replace this infinite by t and we will find out the limit of this whole integration as t tends to infinite. So we will write down this integration as limit t tends to infinite, integration from 0 to t 1 upon x square plus 1 dx. Now we will find out the integration of 1 upon x square plus 1 according to the formula integration of 1 upon x square plus a square, that is equals to 1 upon a tan inverse x by a. Here a is 1, so integration of 1 upon x square plus 1 is tan inverse x by 1 multiplied by 1 upon 1, so it is tan inverse x and its limit is from 0 to t and its limit is limit t tends to infinite. So this is equals to limit t tends to infinite tan inverse x and its limit is from 0 to t. Now this is equals to limit t tends to infinite. Now for upper limit t, tan inverse x will become tan inverse t. Then after minus sign, for lower limit 0, tan inverse x will become tan inverse 0. Now we will replace t by infinite. So tan inverse infinite is nothing but pi by 2 and tan inverse 0 is 0. So we have pi by 2 minus 0, that is pi by 2. So this is the answer of this integration. Now we will see second example. Evaluate integration from 0 to 3 1 upon square root of 9 minus x square dx. Here the given integral is an improper integral of type 2 because the function 1 upon square root of 9 minus x square is not defined at x equals to 3. The integral is unbounded at x equals to 3. Now integration from 0 to 3 1 upon square root of 9 minus x square, as this function is not defined at x equals to 3, we will replace 3 by t and then after we will find out the limit of this whole integration as t tends to 3. So this is equals to limit t tends to 3, integration from 0 to t 1 upon square root of 9 minus x square dx. Now we will find out this integration according to the formula integration of 1 upon square root of a square minus x square, that is sin inverse x by a. So this is equals to limit t tends to 3 sin inverse x by 3 and its limit is from 0 to t. Now this is equals to limit t tends to 3. Now for upper limit t, sin inverse x by 3 will become sin inverse t by 3. Then after minus sign, for lower limit 0, sin inverse x by 3 will become sin inverse 0. Now we will replace t by 3, so it will become sin inverse 3 by 3, which is sin inverse 1, and the value of sin inverse 1 is pi by 2, and the value of sin inverse 0, that is 0. So this is equals to pi by 2 minus 0, which is pi by 2. So this is the answer of this integration. Now we will see problem number 3 related to this topic, that is evaluate integration from 0 to infinite 1 upon x square dx. Here the given integral is an improper integral of type 3 because its upper limit is infinite and the given function, that is 1 upon x square, is not defined at x equals to 0. The upper limit of the integral is infinite and it is unbounded at x equals to 0. Now the given integration, that is equals to integration from 0 to infinite 1 upon x square dx. Now to solve the integration of third time we will break the limit at a finite value. Here we have taken finite value as 1. So this integration, that is equals to integration from 0 to 1 upon x square dx, plus integration from 1 to infinite 1 upon x square dx. Now we will solve this integration and this integration. We have I1 equals to integration from 0 to 1 upon x square dx. Now this is not defined at x equals to 0. So I1, that is equals to integration from 0 to 1 upon x square dx, that is equals to limit c1 tends to 0, integration from c1 to 1 upon x square dx, as this function is not defined at 0. So we have replaced 0 by c1, and then after we are going to evaluate this integration by taking its limit as c1 tends to 0. Now this is equals to limit c1 tends to 0. Now integration of 1 upon x square. Write 1 upon x square as x raised to minus 2. Now integration of x raised to n dx, that is x raised to n plus 1 upon n plus 1. So by applying this formula, we have integration of x raised to minus 2, that is x raised to minus 1 upon minus 1, which is nothing but minus 1 upon x, and its limit is from c1 to 1. Now this is equals to limit c1 tends to 0. Now for upper limit 1 it is minus 1, then after for lower limit c1 it is minus 1 upon c1, but already we will be having minus sign outside, so it will become plus 1 upon c1. Now as c1 tends to 0, 1 upon c1 tends to infinite, and infinite minus 1 it tends to infinite. So this infinite is the answer of this integration, that is integration from 0 to 1 upon x square dx. Now we will evaluate this integration, that is integration from 1 to infinite 1 upon x square dx. So let I2 equals to integration from 1 to infinite 1 upon x square dx. Therefore I2 equals to integration from 1 to infinite 1 upon x square dx. Now replacing this infinite by c2. So we have limit c2 tends to infinite, integration from 1 to c2 1 upon x square dx. Now 1 upon x square, that is nothing but x raised to minus 2, and its integration is x raised to minus 1 upon minus 1. So this is equals to limit c2 tends to infinite minus 1 upon x, and its limit is from 1 to c2. Now this is equals to limit c2 tends to infinite. Now for upper limit c2 it will become minus 1 upon c2, and for lower limit 1 it will become plus 1. Now as c2 tends to infinite, 1 upon c2 or 1 upon infinite tends to 0, and 1 minus 0, the result is 1. So this is the answer of this integration, that is integration from 1 to infinite 1 upon x square dx. So I equals to I1 plus I2, and the value of I1 is infinite, plus the value of I2, that is 1, and which is a finite value. And infinite plus finite value, the result is an infinite value. So this is the answer of given integration. So in today's lecture, we have discussed actually what is the improper integral. Then after we have discussed improper integrals of type 1, type 2 and type 3. And we have gone through the examples related to all the types of improper integrals. Thank you for watching this video. I will see you in the next lecture.